All right, let's go over this. This right here was a hint to help you answer number 1. The best way to separate salt from water is with the use of what? This is if I have a salt water solution. How do I separate the salt from the water? You got it? B, heat. Absolutely. When I add heat to change a liquid to a gas, what is that called? When I go from a liquid to a gas? Not condensation. Evaporation, another Asian word. Evaporation, whether I'm boiling it or just leaving it out on the counter, it's evaporation. That's how they make rock candy. They have a sugar solution, they stick a stick in it, they let it evaporate, crystals form on the stick. That's all it is pure sugar crystals. I put 2 phase changes up there because when you're making crystals from a solution, there's 2 phase changes going on. One is the evaporation of a liquid to a gas. The other is moving from a liquid to a solid. Not exactly freezing, but it is a phase change. When we take away heat, we change things from a liquid to a solid. So it's actually 2 phase changes going on. We're taking a pure liquid solution. Part of it is evaporating, part of it is turning to a solid. Number 2, which of these is an element? Raise your hand if you've got this one. What you got?
B.
It is B. O2 is oxygen. Every other one besides B has 2 elements.
Oxygen on this thing just says O. On this.
Yeah, O is 1. O2 is 2 atoms, but 2 atoms of the same one is still an element. You can have O16 if you wanted. Still an element. Because it's only one type. KBr is potassium bromide, so it's 2 potassium and bromide. 2KCl is 2 molecules of potassium chloride. And FeO2 is iron oxide or rust. Those all have 2 elements. The only one that has 1 element is oxygen. It's 2 atoms, but it's still just an element. Number 3, a student passes a magnet over 10 grams of powder. 4 grams of powder stick to the magnet. 6 grams do not. So this substance is a what? This one's a little tricky. You have to think about it. You got it?
Mixture.
Mixture. Very good. It is a mixture. If I can separate it by just using a magnet, that means that those 2 substances weren't bonded chemically. They're easily separated, so it must be a mixture. I may not be able to separate them using my bare hands, but if I've got a magnet, that's fine. That means they weren't chemically bonded together. So make sure you have the questions and answers for those. Quick reminder, you will have your quiz retake tomorrow. That will be your last opportunity to improve your quiz grade. I will take the higher of the 2. Silly hope the second one is higher. Alright, I want you to take 2 minutes to read over these questions. You do not have to know the answers of them right now, but you need to be familiar with them because the brain pop video I'm going to show is very fast paced. And it's going to be hard for you to read the questions and listen for the answers. Read over them for a few minutes, be familiar with them, so that when it comes time with video. Nope. I eliminated one of the answers for you. You're welcome. That you only have to choose from 3 for each question. Does everybody have a periodic table at their desk? Do they not have a periodic table at their desk? A yellow periodic table? Alright, if you're talking, I assume you're ready for the video. Just in time. Alright, I will be calling on people randomly to answer, so make sure you do your best to answer.
Dear Tim and Moby, please make a movie about the periodic table of elements. From Lauren. Sure. You're overreacting. It's not that complicated, really. The periodic table of elements may look complicated, but considering it's a list of all the chemical elements that occur in the universe, and then some, it's actually pretty simple. It categorizes elements according to the properties of their atoms. Atoms, you'll remember, are the smallest unit of an element. They're made up of a nucleus composed of protons and neutrons, and a number of electrons orbiting in different shells, or orbitals. It's the numbers of protons, neutrons, and electrons in an element's atoms that determine its properties. That's right, Moby. The configuration of these 3 particles is the only thing that makes one element different from another. The modern periodic table of elements organizes elements so that it's easier to see how elements relate to one another. Well, first off, the elements are listed by their atomic number, or number of protons in their atomic nuclei. You can find that here, along with the element's symbol, name, and relative atomic mass. You can read across the table this way. Hydrogen has 1 proton, helium has 2, lithium 3, beryllium 4, boron 5, and so on. Reading across this way, those sets are called periods. You remember how electrons orbit in shells, right? Well, periods describe the number of electron shells that elements have. Period 1 consists of only 2 elements, hydrogen and helium. These guys only have 1 electron shell. Period 2 contains elements with 2 electron shells. The first shell contains 2 electrons, and the second one can hold up to 8 electrons. As you read across a period, that outer shell fills up with electrons. So lithium has 1 electron in the outer shell, beryllium has 2 electrons, boron has 3, and so on. By the time you get to the far right side, the outer shell is completely full. The 6th and 7th periods contain so many elements, scientists took some out and put them underneath. Well, the configuration of electrons in an atom's outer shell plays an important role, too. It determines what other kinds of elements it can bond with. On the periodic table, elements with similar configurations of electrons are arranged in vertical columns called groups. Groups are numbered 1 through 18. In some of these groups, the elements don't have that much in common, but that's not always the case. Take a look at group 1. All the elements in this group have exactly one electron in their outermost shells. That means they're likely to form positive ions. They're also likely to bond with elements in group 17, whose outer shells are one electron shy of being completely full. The periodic table is also organized by color into different categories. These categories are organized by properties of the elements. Alkali metals, like sodium, all can react with water to produce alkaline solutions. Alkaline earth metals, like calcium, also produce alkaline solutions when combined with water and are found all over the place on Earth. Transition metals, like iron, are strong and shiny. Ore metals, such as lead, are soft with low melting points. Semi-metals, like silicon, conduct electricity only under certain conditions and are useful in electronics. Nonmetals have a variety of properties and include the carbon, nitrogen, and oxygen vital to life on Earth. Noble gases like helium and neon have outer electron shells that are full, and so they don't often react with other elements. So there you go, the periodic table of elements. Well, I've seen tables with elements going all the way up to atomic number 118, but any element above 92, uranium, is too unstable to occur in nature and has to be made in a lab. Another cool thing about this table is that because it's based on number of protons, and you can't have half a proton, scientists are pretty sure there aren't any holes in the table. Using an early version of the table, scientists were even able to predict the existence of elements like neon and germanium before they were even discovered. Yeah, see? Well, that wasn't too hard, was it? Yeah, Moby, you give up too easy. He faints too easy, you ask me.
Alright, take a minute, look over any answers that are missing, think about it. How many people need to watch this video again? Okay, I'll give you 1 minute to answer what you can, and then we'll watch the video again, and then that's it. You should not be talking, this is what you know, not what your neighbor knows. Again, there should be no talking. Alright, let's watch this video one more time, and then I'm going to call on people for answers.
Dear Tim and Moby, please make a movie about the periodic table of elements. From Lauren. Sure. You're overreacting. It's not that complicated, really. The periodic table of elements may look complicated, but but considering it's a list of all the chemical elements that occur in the universe, and then some, it's actually pretty simple. It categorizes elements according to the properties of their atoms. Atoms, you'll remember, are the smallest unit of an element. They're made up of a nucleus composed of protons and neutrons, and a number of electrons orbiting in different shells, or orbitals. It's the numbers of protons, neutrons, and electrons in an element's atoms that determine its properties. That's right, Moby. The configuration of these three particles is the only thing that makes one element different from another. The modern periodic table of elements organizes elements so that it's easier to see how elements relate to one another. Well, first off, the elements are listed by their atomic number, or number of protons in their atomic nuclei. You can find that here, along with the element's symbol, name, and relative atomic mass. You can read across the table this way. Hydrogen has 1 proton, helium has 2, lithium 3, beryllium 4, boron 5, and so on. Reading across this way, the sets are called periods. You remember how electrons orbit in shells, right? Well, periods describe the number of electron shells that elements have. Period 1 consists of only 2 elements, hydrogen and helium. These guys only have 1 electron shell. Period 2 contains elements with 2 electron shells. The first shell contains 2 electrons, and the second one can hold up to 8 electrons. As you read across a period, that outer shell fills up with electrons. So lithium has 1 electron in the outer shell, beryllium has 2 electrons, boron has 3, and so on. By the time you get to the far right side, the outer shell is completely full. The 6th and 7th periods contain so many elements, scientists took some out and put them underneath. Well, the configuration of electrons in an atom's outer shell plays an important role, too. It determines what other kinds of elements it can bond with. On the periodic table, elements with similar configurations of electrons are arranged in vertical columns called groups. Groups are numbered 1 through 18. In some of these groups, the elements don't have that much in common, but that's not always the case. Take a look at group 1. All the elements in this group have exactly 1 electron in their outermost shells. That means they're likely to form positive ions. They're also likely to bond with elements in group 17, whose outer shells are 1 electron shy of being completely full. The periodic table is also organized by color into different categories. These categories are organized by properties of the elements. Alkali metals, like sodium, all can react with water to produce alkaline solutions. Alkaline earth metals, like calcium, also produce alkaline solutions when combined with water and are found all over the place on Earth. Transition metals, like iron, are strong and shiny. Poor metals, such as lead, are soft with low melting points. Semi-metals, like silicon, conduct electricity only under certain conditions and are useful in electronics. Nonmetals have a variety of properties and include the carbon, nitrogen, and oxygen vital to life on Earth. Noble gases like helium and neon have outer electron shells that are full, and so they don't often react with other elements. So there you go, the periodic table of elements. Well, I've seen tables with elements going all the way up to atomic number 118, but any element above 92, uranium, is too unstable to occur in nature and has to be made in a lab. Another cool thing about this table is that because it's based on number of protons, and you can't have half a proton, scientists are pretty sure there aren't any holes in the table. Using an early version of the table, scientists were even able to predict the existence of elements like neon and germanium before they were even discovered. Yeah, see? Well, that wasn't too hard, was it?
Yeah, Moby. You give up too easy.
He faints too easy, you ask me.
Alright, take another minute, finish the answers you may have missed, and then get ready to tell me what you got. Ladies, you should not be talking. Okie dokie. Let's see how you did. Number 1 says, what characteristics are shared by all alkaline metals and alkaline earth metals? Rigo, do you have the answer?
C.
It is C. Very good. If you are an alkaline metal or an alkaline earth metal, when you're combined with water, either way, you're going to make alkaline solutions. That's what you have in common. You're in different parts of the periodic table, but when you're mixed with water, same thing happens. That is C. Down to take your hood off, please. Thank you. Right here. Nope, you're right. Number 2, carbon has an atomic number of 6. What can you conclude about carbon from this fact? And that goes to Melanie. It is A. Very good. It has 6 protons. If it has any more than 6 protons, it's no longer carbon. Number 3, noble gases are sometimes called inert gases. What can you infer about the meaning of the word inert in chemistry? That goes to Nazaria. Shh. You got 25% chance of getting it right even if you guess, so we never leave a question unanswered. Good guess. B, it refers to substances that do not react with other substances. If you're inert, like you guys probably are inert some Saturdays or Sundays where you just lay around, you don't want to interact with people, you don't do a whole lot. Same thing with noble gases in that last column. They don't do a whole lot of reacting. They're inert. That is B. Number 4. And even if you didn't know what color it was, you should be able to answer this question. What do the orange and yellow spheres represent in this model of an atomic nucleus? That goes to Deontay. What you got? B, very good. Protons and neutrons. You didn't even have to have a picture to be able to answer that question. There's only 2 things that could be in the nucleus, protons and neutrons. That's B. Number 5. And the red highlighted part is that top, the bold in that picture. What do the elements highlighted in red have in common? And that goes to Takajani. It is D, very good. Every row or period has the same number of electron shells. Do y'all remember that model on the board we had where we wrote notes about it and it had the nucleus with circles around it, like rings around it?
Yeah.
It's on page 10, I believe. That is, those circles are the shells. Those are the ones that are in the model. They're not really shells in real life, but it's just what we call them. All right, number 6. Which of the following is a true statement? Santiago.
C.
It is not C, but you're very close. That's the second most popular answer. No. Daniel, do you know? It is A. Very good. Periods form horizontal rows, and Y'all got tripped up about this on first day. Marvin, pick your head up, please. Thank you. Remember, horizontal is left to right. It's like looking at the horizon or the x-axis. Vertical is groups. Vertical is up and down. Like if you're in football and you got to measure your vertical jump height. That's up and down. So that would be A. Number 7, what is true of all atoms? That goes to Deborah. You say D? Very good. If you're your first one to get it right, first time all day. They contain at least 1 proton. If you have 0 protons, you don't exist. No such thing. Hydrogen has 1 proton. That's why its atomic number is 1. Everything else has more than 1 proton. So all atoms have at least 1 proton. Number 8, what is one key physical difference between transition metals and poor metals? Alondra. Very good. B. Hardness. They did not use the word hardness in the video. They used the word strong. They said that transition metals were strong, poor metals were soft. That's the difference between, say, a sheet of steel and a sheet of aluminum. You can crumple a sheet of aluminum with your bare hands. You can't do that with a sheet of steel, but they're both metals. But they have different physical properties, and by the time we're done, you should be able to know, based on where an element is out on the periodic table, as to what its physical properties are. Number 9. This goes to Abdiel, and I'm going to tell you, Abdiel, this one is tricky. If you want to find a sample of fermium, which is an atomic number of 100, where would you look? Where would you be able to find it? Which one? Are you serious? First time. Only one that got it on the first try. D. You'll only find that in the science lab. That's the only place you'll be able to find it. Because remember they said anything above number 92, which is uranium, that does not occur in nature. 92 on up is man-made. We make it in the lab. That's the only way you can find it. Most of those are highly radioactive or dangerous as well. All right, last one, number 10. To become positively charged, an atom must do what? And this goes to Rihanna. It is D. Y'all are on it today. Very good. D. Lose an electron. Remember, atoms like to be balanced. They like to have the same number of protons, same number of electrons. What charge is a proton? Positive. What charge is an electron? Negative. It's a balance. If you take away an electron, you now have more positives than you have negatives. So it's a positively charged ion. Don't mess the protons, because if you mess the protons, you're changing what the substance is. But taking away or gaining electrons changes the charge. All right, what I want you to do. Who has the hole puncher at their desk? No, it's back there. Okay. Take the hole puncher, Takashi. You'll start it. I want you to hole punch this. Now that you have the correct answers, put it in your 3-ring binder. This is your study guide for what we're about to dive into. And I also want you to open up your notebook to page 14, which will be a blank page. We're going to add some notes. Very, very brief notes. Remember, if for some reason you do not have your notebook today, which is a no-no, you're supposed to have it every day, you better get a piece of paper to write this down and add it in later. This goes on page 14. I should see notebooks out. The title of this page is going to be Elements. Make sure you update your table of contents. your periodic table and find fluorine. Look on your periodic table and find fluorine. Elijah's group, I'm going to break up that band tomorrow. Y'all can't sit together and just be mumbling the whole time. It's just not going to work. All right, on the periodic table, this orange laminated periodic table you have in front of you, this is a copy of what they give you on the EOGs and benchmarks. So unless they make some really big changes in the next few months, this is what you're going to get on your benchmark coming up in October, November-ish. There are many different versions of the periodic table. Some of them give a lot more information than others. For example, mine on the wall and back there gives you a picture of what we do when we use the element in something. Not every periodic table is going to have that. There are 4 basic parts of the periodic table for each element that you have to know. And by have to know, I mean you have to be able to label them. I am not going to make you memorize the periodic table of elements. 2 reasons. 1, you're going to have a periodic table given to you for all your tests. It's a resource. Not many scientists in the world have the whole periodic table memorized completely because we have resources to refer to. It's what the world is. We have periodic tables to look at, so why would we memorize them? However, in chemistry, in high school and college, you will have to memorize most of it. I know in high school chemistry, I had to memorize the first 30 or so elements. And then by college, you had to memorize pretty much the whole thing. I don't know why, they do it. So, this periodic table that you have, I will give you this as a reference for all your test quizzes, all of your EOGs, benchmarks. This will be a reference for you. What you do have to know is what the different groups and periods mean, what they have in common, the different sections of the periodic table, because the one on Brain Pop was colorful, and we're going to color one too. However, the one you'll get for your EOG will not be colored. So you need to know what the different sections are and what that means. If you're an alkaline earth metal, if you're a noble gas, where are you at on the periodic table? I should be able to give you an element, if you look at the periodic table and go, oh, it's in this section, so it's an alkaline earth metal, and it likes to react with elements in period 4.
It's different on those. Like,
Yeah, that's why you shouldn't be doing anything with that yet. We're not there. We'll get that, honey, don't worry. So don't worry about memorizing this, but you need to be able to use this tool. I will give you the tool. What we're going to be concentrating on over the next couple days. All right. So for each element on the periodic table, you're given 4 main indicators or descriptions. One is the element name. The elements are named by the people who discover them. They are named sometimes for what they're used for. Sometimes they're named after a person, like Einsteinium. What would you say Einsteinium is named after? Albert Einstein. Yep. So whoever finds it gets to name it. That's the rules. That's why you're like, why is it named that? Why is it look like? That's why. That's also why your chemical or elemental symbol may be different than what the name is. So fluorine, this is its symbol, F. Lead, its symbol is Pb, like peanut butter. It's like that because whoever discovered it, either it's like, well, we already have Keeping. It could be his initials. That's something that you guys are going to research soon in your element project if you have that element. But every element has a 1 or 2 letter symbol, never more than 2. Every element has an atomic number. Y'all can sweep my floor before you leave. And the last thing that you'll have on the periodic table is the atomic mass. So if I give you this block of information, you should know what's the atomic number, what's the atomic mass, what's the name of the element, and what's the element symbol. You should be able to do that, and don't be surprised if that's on some sort of pop quiz in the future. Now on EOG's benchmarks, tests, test makers, they love to give you an element and say, not even this whole information, they may give you cesium. And they'll say, all right, what is all the information you have for cesium, including the subatomic particles? You should be able to go to a periodic table and go, okay, cesium, atomic symbol is CS, atomic number is 55, atomic mass is, you should be able to say all that, and you should be able to give the subatomic particles. How many protons does it have? How many electrons does it have? How many neutrons does it have? And I am going to give you an acronym to help you remember how to find that information. Eight man. Eight man. Eight man. A stands for atomic number. Makes sense, right? A, atomic number. Does anybody remember what the atomic number means? If I have an atomic number of 9, what subatomic particle does that tell you it is? Neutrons, electrons, or protons? Protons. So you can guess what the P stands for. Atomic number equals protons, which also equals electrons, because we like to be balanced. We like to have the same number of positives as negatives. We like to equal out. So atomic number equals protons, which equals electrons. What is fluorine's atomic number? It is 9. Fluorine's atomic number is 9. So how many protons does it have? 9. How many electrons does it have? 3. How many electrons does it have? 3. Let's try again. Atomic number is 9, which equals protons, which is 9. How many electrons do we have? 3. No. Atomic, look at what we wrote up there. The APE, atomic number, equals protons, which equals electrons. Atomic number is 9.
Oh.
Protons is 9, which means electrons must be
9.
9. Yes, don't overthink it. It's exactly how we wrote it. What strange you learning? On page 14 of our notes right now. Look on your yellow periodic table. Find. Make it too easy. Find iron. It's somewhere in the middle top. Alright, somebody tell me the chemical or atomic symbol for iron. Fe. It's one of those weird ones where it's like Fe, that has nothing to do with the word iron. Just the way it is. It's kind of, the Latin root word for iron is ferrous, so that's where they get it from, Fe. What's the atomic number?
26.
26. So what is, how many protons does it have?
26.
26. How many electrons does it have?
26.
26. See how that works?
Yeah.
Look for 10. I will tell you. It is, chemical symbol for 10 is Sn. It's on the right side, kind of towards the bottom.
I found it.
You found it?
Yeah.
Sn.
I found it. 50.
Alright, has everybody got it? 50? Atomic number is 50. How many protons does it have?
50.
50. How many electrons does it have?
50.
Alright, y'all should be able to get that. No problem on your test. Alright, next part. We've got ape and now we need the man. What do you think the M stands for? If you had to guess. Mass. It stands for atomic mass. And here's where we need to do a little bit of math. And it's not like give me a calculator math. It's do it in your head math. Atomic mass minus, there's that A, so we know that means atomic number, equals neutrons. So fluorine, what is our atomic mass? Look at what's labeled. What is our atomic mass? Fluorine.
19.
19. What is our atomic number?
9.
How many neutrons do we have?
9.
Eh.
Wait. You subtract that, don't you?
Mm-hmm.
It's 10.
You say it. It's 10. 19 minus 9 equals 10. So atomic mass, right here, 19, minus atomic number, right here, equals how many neutrons we have, which is 10. Look at neon, which is right next to fluorine on the periodic table.
It's 10.
Does everybody see neon? Number 10? What? Yeah, I can take it. Does everybody see neon? It's number 10. Its atomic number is 10. Everybody see it on the periodic table? Does everybody see it? What is its atomic mass? Yeah, atomic mass, not atomic number.
20.18.
Here's the deal. I want you to round
Oh,
to
20.2.
20. So atomic mass is 20. Atomic number is 10. How many neutrons do I have? 10. All right, let's do. That's a good one. Sodium, atomic number 11. All the way on the left-hand side. Fourth one down, third one down. What's its atomic number? Sodium is 11. All right, what's its atomic mass?
23.
22.99, so we're rounding to 23. How many neutrons does it have?
11.
Nope.
Oh.
Atomic mass is 23, atomic number is 11, so 23 minus 11 equals 12. Does everybody see that? Remember, if you remember 8-man, and you can jot it down on your scrap paper, on the side of your test, whatever, write it out. That's all for page 14.
That's a little bit.
All right, we don't have a lot of time. Let's hurry up and finish up. I want you to get out your foldable that I just handed out. We may not have time to color blue today, and that's all right. I want to just record today, so I'm going to go ahead and start studying. One side has periodic table with a couple highlighted features on it. And one side has questions. You see how I do something? It's talent. All right, on the periodic table side of your handout, and y'all are going to get several versions of the periodic table just because we're going to be extremely familiar with it by the time we're done. There are two highlighted sides. One is labeled number 1, one is number 2. One is vertical, one is horizontal. Yes. In between classes. In between classes.
Okay, go down.
We're getting ready to change out here in not too long. All right. Turn over to the questions on back. First question. The area labeled number 1 on your periodic table on the other side. What is that called? The vertical area on your periodic table that's highlighted. What is that called? What do you call one of the vertical columns?
Oh, you're talking about
Do anybody remember from the video what's that called?
period.
Not periods. You said groups. Did you say groups?
Yes.
Okay.
Period is like this.
Yep.
Like this.
Mm-mm.
Yes, it is.
Mm-mm. Y'all get horizontal and vertical confused. It happens.
So I was right just now. You said I was wrong when I said periods. Until she was asking.
Number 1.
Oh.
Up and down, the vertical, the y-axis. Those are groups or families. They're referred to either groups or families. You may see them one way, you may see them as groups on tests, you may see them as families. The way I remember this is I think about, in my head, a mental picture of what it would look like if all the members of my family stood on each other's heads. And with that image in my head, I can't forget that families or groups are up and down. So number 1 is groups or families. Cody, quit talking. All right, second one asked, how many groups or families are on the periodic table? Not 2? Who said it? 18. You don't even have to count. I mean, you can if you want 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. But if you look at the top of your periodic table, they have numbered them for you. They are Roman numerals and actual numbers. So you can see it goes all the way up to 18. So there are 18 groups or families. All right, what are some similarities amongst elements within a group of family? I don't expect you to know that. This is what we're learning. Copy that down. They have the same number of valence electrons and have similar properties. So if you're in the same family, you have things in common. One of the things you have in common is you have the same number of valence electrons. And remember, valence electrons, that's a vocabulary word. Those are the electrons that are in the outermost ring or shell, the electron shell. The ones in the very outermost one, that's where the valence electrons are. When you take your test, if I give you 2 elements, you should be able to tell me if they have something in common based on if they're in the same family and if they're in the same category. You should tell me what they have in common. Last one, I don't expect you to know either, but now you do. Which groups are the most reactive and why? And they mentioned that in the Brain Pop video, 1 in 17. Group number 1 has 1 valence electron in its outer shell. That's it, just 1. Group 17 is missing 1 valence electron in its outer shell. So they both want to find that last single electron bond to make them stable. So the ones with 1 valence electron are wanting to get rid of that electron so they can be stable. The ones with 1 missing are looking to get just 1 more electron, whether they share it, trade it, get rid of it, gain it, whatever. They want to be complete. So that's why sodium chloride, the sodium and the chloride, they bond together so easily because sodium is in the first group, chlorine is in group number 17. Sodium has 1 extra electron. Chlorine is looking for that electron, so they bond real easily. I know it may be a little hard to see. I'm trying to get it so that we can get all this done. And we'll worry about gluing and cutting tomorrow. All right. The number 2, the horizontal, is the periods. This is like how when your core classes, you don't go upstairs. You stay horizontal. You don't go anywhere but on this floor. Same thing with periodic table periods. They are left and right. They are horizontal. They don't go up or down the periodic table. There are 7 periods in total. We do not count the last 2 because they are just taken out of the middle. They just got moved down to the bottom because they didn't have any room to squeeze it in. And if you are in the same period, the same horizontal line, then you have the same number of electron shells, or those rings around the nucleus. You all have the same number, whether it's 1 through 7. Once you have this copied down, stick it in your notebook. Do not lose it, and we'll glue it in tomorrow. Do not forget you have your quiz to retake tomorrow as well. I'll see y'all later. Cody Davis.
Yes, same one you have. Come on, touch your head back, sweetheart. Then the mail extend over here with the on. Okay. You need Cody. He's walk. He walk back out. Man, how many you need Cody? Whatever. He was trying to play Cody. Yeah, we should.
Gentlemen, you're right next to me, and you're supposed to be level 0. That's not cool. Deontay, Elijah, Santiago, you have what you need to discuss, be quiet. David, Lauren,
It's hot.
Oh my God!
Hey, I'm back. I don't like you. I'm cold. I'm outside yesterday. Yeah, because Noah was funny. You gotta know. Because you wasn't funny. Yeah. Oh, she was. Oh, yeah, she said we gotta go. That's funny. You was right there. Y'all actually did. Right. But I gotta get shit right there to tell Lord this. It's hot. It's cold. It's hot. You? You didn't have your jacket? No. Here. You use the order. I was hiding. Really? Yeah. Here, you use the order. Here. I don't. You said yo. I'm sorry. That's racist. They're racist programs. Injustice. This girl's racist. You don't know injustice means. I know you said it's like you don't know what it looks like. It's your daughter. You like that's not you just like I know so what do you say? It's not Steve. They don't say good as Steve. What did they say good as asking goodbye? I knew you took me. And I'm gonna be coming. Why
Alright, I need one. Yeah. sticks. I kind of hope they were already all picked up because I didn't pass any out last period. But yeah, if you see glue sticks or scissors, then we put up, that'd be great. Check around your desk, look for scissors, please. Because the day is colder or cooler, so the air is feeling extra cold. But I'm okay with that. It's better than too hot.
Everyone feels cold and I'm the one who feels okay.
I feel a little chilly, but I'd rather be too cool than too hot.
I feel cold fine. Like some people don't believe me. That's how I was born in the fall. And I say I'm immune to the cold. I'm born in the fall, so I'm able to be immune to the cold. And some people don't believe me.
You should move up north.
Huh?
You should move up north.
No, not that type. Like if it's chill, like depending on how cold it is. If it's like chilly, then I'm okay. You know, like I'm okay and I can try to deal with it. But if it gets freezing cold, then I might have to put a jacket on because then my ability automatically just start to shut down because it's too cold for me to handle it.
Oh well, yeah. That
It depends on how cold it is.
All right, fourth period. I need to turn your voices off. What we're gonna do today. First priority is because I just got the key. I have not messed with these laptops any. I need you guys to get your laptop, make sure it's in good working order, and there's no keys missing or anything. If there is, I need to know about it, and you need to let me know now because the next person that uses your number, if they tell me keys missing and you didn't tell me, then I'm gonna assume that it was you that broke it. So don't get labeled like that. If something's messed up on the laptop, let me know. The second thing we're going to do is for those of you who have, no, let me not go there. Second thing we're going to do is you're going to log on to SchoolNet, check your grades. Third thing, because private sports will be coming out next week, I think. Probably. So check your grades. Keep in mind that we have a quiz retake tomorrow, so your grades can go up. If you have not turned something in, you better turn it in before too many points get taken off. Third thing we're going to do is for those of you, except for Ruben, Tyvon, and Aaliyah, you will get to use the computers to start any of your Genius Hour research. I'll be putting up guiding questions that I want you to use as like a daily log. And then I'll also be passing out folders for you to keep your research in, and you can put your name on the folders. So what I'm going to do is I'm going to call you up a section at a time by number. You're going to come up and get your laptop. If I come over here and check after you guys leave and the laptops are not where they're supposed to be, or they're not plugged in, or not put in correctly, then I'm going to flag your number as not being able to use laptop. Not putting back correctly, you don't need to be using them. And it's cold right here. I'd rather be too cold than too hot. Last year, y'all remember the end of the year, it was too hot. All right. If your laptop's number 1 through 5, and if you forget, it's up on there, you are the first. You should be number 1 for every one of your classes, number 2 for every one of your classes. Number 22.
Right, look at
How about this? Alright, y'all have a seat. I'll call out the numbers because obviously these are not in order. Again, I just got the key, so I didn't do it. Alright, number 15 and number 19. number 15 will be Sean. Number 19, Brian. And just in case I need to remind you, hold this like you would if it was yours. 2 hands at all times. No swinging around. These do not have the handles on them. Hold with 2 hands, please. I think they're brand new, so be gentle. 18, to Seth. 17, to Seth and Logan. Make sure you log on to your game. Log on when you're done. 16. These are yours. And 20. Okay, they weren't. 26. Don't have a 26. Number 2. Number 3. Number 6. Elijah. Number 7, number 8. Number 7, number 8. Number 8. 5, call your number more than once. You don't get a computer. So if somebody around you is talking, tell them to be quiet so you can hear your number. 22, 21. Oh. 11. 9, 5. I'm 5. 10, 4. 10, 4. They may not have a computer.
Yeah, we got. You said D? I got That's because I'm dressed 23. We are.
Alright, real quick. Listen. Listen. In case you have forgotten, your login is your email address, which should be the first four of your first name, first four letters of first name, dot, first four letters of your last name, and last four numbers of your lunch number. Lunch last four. At student.lexcs.org. Don't forget the student part. Your password is your lunch number. A lot of times people forget the student part. So, Ruben, yours is not working. Oh my God. Alright, there's a lot of talking for what y'all are supposed to be doing. If you're done looking at Power School and you have turned in your internet form, you should be researching.
Oh, you're buying this.
So,